Hello, everyone. Thank you for joining another podcast. My name is Mondo Mikhail. I'm the Systems and Solutions Architect for ADLINK Computer. Today, we've got a very, very interesting topic. We're talking about AI and security for edge compute, but focused on the medical field. I'm very pleased to have Maciej Halasz from Timesys Linux. He's the Vice President of Business Development and Technical Sales. He has 25 years experience in the embedded computing with a focus on embedded Linux and real-time systems. Hi, Maciej. How are you today? It's a pleasure to have you.
Thank you. Very nice to be here. Thank you for having me, Mondo. I'm excited for the discussion today.
Yeah, this is especially an interesting discussion today. So today's discussion is AI security for edge compute, but specifically focused on medical devices. AI is such a broad area, machine learning and AI. Most of us, I think myself included, encounter AI in a lot of the most current types of implementations. It seems like Chat GPT has proliferated. Everybody uses it. They think it's the greatest thing, and it's revolutionizing how we interact with AI and machine learning. Also AI for cell phones, how it produces data, focuses on what we search. But help us understand how AI has been used in the medical field specifically, and what advances it's brought.
Yes, exactly. And I think that AI is also very popular in automotive, right? Because this is where the self-driving capacity, everybody kind of recognizes all that smartness in a car
Yeah,
coming
absolutely.
from AI. And healthcare is no different than in other market segments. The AI has made its way to different medical domains. It helps with natural language processing, for example. You can extract clinical insights from some textual notes. AI is also commonly used in speech recognition, and in the hospital environment, you can have clinical notes during surgery being dictated by a doctor. And those notes can be logged somewhere in a hospital system as the surgery progresses. Um, you can also use speech recognition in certain testing. So if there are certain, I don't know, maybe patients' voice issues and or medical symptoms that can be identified by certain voice patterns, speech recognition comes in quite handy. Um, but I think that we all think about AI and maybe video or computer vision and how that is used to identify different patterns and learn from those patterns, so that in an intelligent way you can assist better medical personnel in things such as tumors and lesion detection, or there are, you mentioned robotics, and robots are also present in a hospital operating room, right? So computer vision can be viewed as AI in healthcare, assisting, or robot surgery assisting with visual guidance.
Right, right.
Um, and then also maybe the last field that I would mention is maybe certain anomaly detection, which when you analyze complex signals coming from a human body, such as maybe your EKG, that you can collect over extended periods of time, if there are certain anomalies in that signal, before doctor even takes a closer look at it, an algorithm and AI with machine learning can probably provide early detection of certain illnesses and alert medical personnel of possible issues.
Right, right. That's fantastic. I had a interesting friend who actually had a family history of a very specific disease process. She was not afflicted by it, but exactly what you said, she was able to go in and get genetic screening, which identified a higher risk in her because it had a genetic predisposition for it. And without that, you didn't really have concrete evidence that there could be an issue in her future health. So that's fascinating. Also, one thing that comes to my mind is like the Human Genome Project that's been done, maybe a decade or so ago, but that could have never been done without the specific compute and also AI that goes into that for the reasons that you just stated. So many wonderful trends.
Yeah, and I think that part of confusion or how people maybe wrongly think about artificial intelligence is that it's an algorithm, and it's not really an algorithm. It's it's basically the algorithm that is used to train the data set, and then based on that, you can provide future data sets from other patients, and based on what the data set has already learned, you can provide approximation as to what it is, right? It helps us analyze data.
Right, right, and it helps also give us statistical advantages when we try to make decisions based on that data. That's uh, that's fascinating. Also, my experience recently in the hospital with myself and a relative is I couldn't believe the amount of IoT devices in the hospital. We've all seen them, but they've become so much more intelligent, and how circuits have evolved and become so much more smaller, and everything is now Wi-Fi or network enabled. These devices generate data, and it transmits that data between certain facilities within the hospital to create these advancements in diagnostics and how rapidly you can analyze this data. Help us understand what kind of security implications that brings out.
Indeed, there is more and more of those smart devices installed within the hospital network, and they no longer are viewed as a single self-contained intelligent device. The intelligence comes from all types of data that is being collected by different IoT nodes, sensors, inputs. And when you look at a device with machine learning, with artificial intelligence that's installed on it, you can view, you can actually see various different risks and security flaws, maybe. You can view the risks associated to data privacy attacks. If the data that's arriving at the machine is somehow changed or manipulated, it can cause very weird output from the model itself, right? Because the model might not take into account correctly the data that are being fed. There is this training data poisoning also, which is a risk for artificial intelligence. So before you start feeding any data, you have to train the model. You have to make it intelligent. So if at that point in time the training data is affected, if a hacker gains access um, to our training set, then of course the model is not going to do what it's intended for. There's also an issue of adversarial inputs where you can inject certain information into the model itself. And of course, a big issue is of model extraction. If you look at the model that is created based on artificial intelligence training data set, it's an actual IP for the company. Because if a medical vendor builds, I don't know, an analysis device of sorts that looks at skin pictures and tries to identify whether this is cancerous or not, it takes a lot of training and time to create a model that is capable of accurately discovering other cancer in samples. So now, if a hacker breaks into a hospital device and is able to extract the model, it's like stealing IP from a company, right? So it's important to implement necessary security measures around intelligent devices to protect the models, to protect the intelligence that companies spend probably a lot of money and time to develop.
Right. Right. That's very interesting when you put it in that framework. Now, once this data set gets trained and it's reliable, producing reliable results, you deploy a model on devices, whether they're handheld devices, whether they're diagnostic equipment, and those devices run on small form factor type of machines. All of these are running operating systems. A lot of them now are running operating systems based on Linux or Linux type of operating systems. And as those models get deployed, how then does the aspect of security roll in at the operating system level, which is running these models, producing this data and distributing it throughout a medical systems organization?
Mhm. Yep, and this is where I think regulation comes into picture a little bit as well. We can probably talk about this a bit more next, but there is requirements in place that come from regulation or regulatory bodies that put emphasis on implementing security measures in medical devices. And that includes implementing authentication of the software and models that are running on a device. So the device is never going to accept a model that's not coming from an authorized vendor. You should implement encryption to protect the IP. So the model should be encrypted, and the encryption should be efficient enough to not impact the performance. You can harden the device. You can implement various security measures around device communication. So you talked about, Mondo, about how devices in a hospital right now communicate with each other. So that communication should be secured or must be secured. Those devices run software. Software is not a static thing. Every day there are new vulnerabilities that are reported against the software that runs on devices, medical included. What regulations basically require companies is to put a security monitoring process in place for devices that are released in the market, such that you can be aware of new vulnerabilities that are reported against that software that runs already in the field. And so that as a medical device vendor, you can take action. You can let the hospital know, hey, this device can be potentially hacked through such and such means, or you should upgrade to the new firmware that we are providing right now, right? So there are different actions that come out of that. But yes, implementing security is paramount to keeping the artificial intelligence, the IP, the models secure.
Right, right. Yeah, that's very interesting. Tell me, Timesys has some innovative approaches to this. I noticed you have a couple of very innovative products that can really help devices time to market quicker while also guaranteeing security of that transmitted data. Can you help us understand?
Yes, absolutely. There are basically two products or three products, if you will. First one is called VigiShield, and it's a product that is designed to help companies implement security measures of the device, secure boot, chain of trust, encryption, closing ports, and various other security measures, which are pretty common in requirements for medical devices. We have then also a solution called Vigilus. Vigilus is a cybersecurity monitoring tool. It's basically a solution, a tool that takes as an input software bill of materials for your product, and it can report continuously on new vulnerabilities that are reported against that product. So it structures nicely how you are consuming the security feed for the product and actions that are coming out of this. This is something that's required by FDA, EMEA, and other regulatory bodies across the globe. And then we also have an offering called BSP Maintenance, where it's a Timesys team that's using Vigilus tools. We monitor the software, the product software for a vendor, and we are implementing fixes for available fixes for CVEs. And then we release that to a vendor who then runs final checks, builds the final firmware, and is able to very efficiently and quickly release the security fixes in a field.
That's a very innovative approach. I mean, it really takes security to the next level, down at the small device level, as well as those larger diagnostic type of machines. How has this been deployed so far? Can you help us describe some success, some use cases?
Yes, we have a lot of customers in medical field who basically integrated our Vigilus tools with their CI/CD systems and created an automated process that tracks the security issues. It helped them with submission of various documentation to regulators, so FDA, and there is also EMEA that has a set of requirements. There is a medical device requirements document as well, by which the medical device vendors live. So these solutions not only help solve the problem, but Vigilus helps with acceptance, right? With the final blessing by regulators that this device has, in fact, a security process implemented, and that it follows the guidelines.
That's wonderful. I know through my experience, security is usually more of a reactive type of workflow. Threat is identified, you react to it, but a lot of people don't consider security as being much more proactive, looking at the data as it's being generated and how to identify those threats in real time. And that seems to be especially important in the medical field.
It's great that you talk about, because this is also changing, right? This security is no longer an afterthought. The new regulations. So in various regulations, there was a language used so far that certain features should be there. It wasn't a requirement, and over the past year, that language started to change, especially around security. Those regulations nowadays use the words such as essential, must have. So also certain regulations right now introduce liability for medical vendors in case of device being hacked if the medical vendor doesn't have those security measures. All that is driving the adoption of security measures in medical products. So it's no longer something that needs to be added at the end of the product implementation. Security right now, through the shift left approach, is being considered as a must-have piece of the initial design of a device, and then of course follow on implementation.
Right. Wow, this is such a fascinating discussion. Maciej, I want to thank you for spending the time with us today, helping us understand how security is working, especially with AI in the medical field. This is a very important discussion, and thank you for helping educate everyone on how this is being implemented. Also, thanks for discussing your innovative approach through Timesys.
Thank you for having me.
We hope you've enjoyed today's podcast with Maciej Halasz of Timesys Linux. Thank you for joining us, and we look forward to the next podcast. Thank you.